Welcome to the 8.2 Part C lesson video. So we're jumping back to 8.2. Today we're going to be talking about something called radians. Now, a little bit more of a challenging topic for some people. Radians is an alternate form of measuring angles rather than degrees. So we'll talk about it, and I'm going to use some other tools in class to help it make a little more sense. So if you're not fully understanding of how radians work by the end of today, that's okay. We will help make it make more sense as we keep going. So let's go ahead and dive on in, and we'll see where it takes us. So we're basically covering this bottom bullet point today is that we can use radians and degree measures for all the stuff we've been doing so far. Radians is essentially just an alternate version of angle measures. All right, so this is a part that I do like to do in class a little bit more. So something you guys will see in class more. I got a nice animation that helps kind of explain what a radian is, but I'll do my best to explain. So a radian is a set unit of measurement that is proportional to every circle. So the way a radian works is you're going to take the radius of a circle, and you're going to take that length and you're going to bend it and wrap it around the outside of the circle. Whatever amount of that circle that is covered, whatever arc is created, is called a radian. That distance of the radius being wrapped around the outside is 1 radian worth of a circle. Now, the great thing about this is it's defined by the circle itself. 360 degrees is an arbitrary number. There's no reason why we use 360 rather than any other number, other than it's just divisible by a lot of stuff. So a radian is much more based in mathematical reasoning rather than just some arbitrary number that was picked because people liked it. So that's what a radian is. That might be a little hard to understand or conceptualize. We'll go over this a little bit more. But what you kind of need to realize is that there are 2 pi radians in a circle. And that's where the circumference formula, 2 pi times the radius, comes from for circles. And yeah, so there's 2 pi of these radiuses that would wrap around the outside. All right, so if we are converting between degrees and radians, there's a pretty straightforward, pretty handy-dandy little formula. It starts with what we just said, that there are 2 pi radians in 360 degrees. So if we simplify that a little bit, we get that every 180 degrees, or every half circle, is equal to pi radians. So pi is 3.14, just like it always has been, and that is equal to 180 degrees, or half of a circle. So depending whether we're going from degrees to radians or radians to degrees, we just need to multiply by this proportion. If you're going from degrees to radians, you multiply by the pi over 180. Now the way you know that you did this correctly is degrees, it'll have a degree in the top, and this one will have a degree in the bottom. So we want to essentially cancel those out. We want to get rid of the degrees and leave ourselves with the pi, which would make radians. Likewise, radians, a lot of time, it'll give you a pi value, say some amount of pi, and that'll allow us to cancel out with the pi on the denominator when we're converting the other way. So whatever you're trying to turn it into goes on top, whatever it was goes on bottom. So if it was degrees and you want radians, the pi goes on top, the degrees goes on bottom. If you want degrees and you were given radians, the degrees goes on top and the pi goes on bottom. Other than that, it's just a pretty simple multiplication problem. You simplify the fraction. These are ones that you leave as exact fractions, so no decimals as much as is possible. And we'll go ahead and do a couple examples of that right now. All right, so if we want to convert these from degrees to radians or radians to degrees, all we need to do is multiply by the proper proportion. So if we're going from degrees to radians, that means we want to get rid of the degrees. So on this first one right here, we're going to multiply by pi over 180 degrees. That's our conversion factor. The degrees get rid of each other, and we get left with 30 pi over 180 degrees. Now, this can simplify, and so we're going to go ahead and try and simplify it. First of all, we can get rid of the zeros, divide by 10, and we can divide those both by 3. 3 divided by 3 will become pi, and 18 divided by 3 will become 6. So 30 degrees is equal to pi over 6. What about this other one? 5 pi over 3. This time we are given radians and we want degrees. Now the way we know it's radians is, first of all, there's no degree symbol. The degree symbol is how we tell something as degrees. If you have degrees, you get a degree symbol. If you don't, it's automatically radians. The second way we tell it's radians is it has that pi in it. So what we're going to do is we're going to multiply by 180 over pi. We'll be able to eliminate those pi's. They'll reduce away. And we're left with 5 times 180 over 3. So we can go ahead and do that calculation. 5 times 180 divided by 3, and we get 300. Oops, didn't change the color. We get 300 degrees. 300 degrees. There we go. So I just did 5 times the 180 and then divide by the 3 to get that calculation there. You could have also simplified ahead of time, but I think it works just as well. All right, so that's converting. So if you want to go degrees or radians, you multiply with the degrees on bottom, so the degrees go away. If you want to go radians to degrees, you multiply with the degrees on top, so that way the radians go away. I should put a degree symbol right there, but otherwise that should look good. All right, now one important little thing, I kind of specified this to be before, something to be careful of, is that if you want degrees, you either have to label it with the word degrees or a degree symbol. If you don't put the degree symbol and you don't say degrees, it is assumed that you're talking about radians. So radians is the default, and if you don't give angles or degrees, you're assuming that the angles are in radians. Now, the issue with that is a 30-degree angle looks like this. A 30 radian angle looks a lot different. Remember, 1 radian's about 1/6 of a circle. So if you do 30 radians, that means you're wrapping around like 5 times to get to this location. So be very careful. If you say degrees, if you want degrees, make sure you put the degree symbol. If you were to just write 30, we're going to assume you mean radians, which is a much different outcome, much different angle. All right, when we find coterminal angles in radians mode, this is something that we were doing before. The only difference now is rather than adding 360 over and over, we need to add 2 pi over and over. Now this is a little bit tricky because we're dealing with fractions, so when you're adding 2 pi over and over, you need to add fractions that are equal to 2 pi. So for example, with this first one here, what I'm going to do is I'm going to add 2 pi worth of a denominator of 3. So for me, what that would be is 6 pi over 3. If I were to simplify 6 pi over 3, it's 2 pi, but I want the denominator to be the same, so I'm going to add chunks of 6 pi over 3. So what I have here is I have 2 pi over 3 plus 6 pi's over 3. I have a total of 8 pi's over 3. This is a coterminal angle to my original angle of 2 pi over 3. It's just differing by 2 pi, which in this case is 6 over 3. I could have also subtracted. I didn't have to add. If I wanted to do this again, this one's a little bit different. Now my denominator is 4. Double 4 is 8, so I'm going to add chunks of 8 pi over 4. So 7 pi over 4 plus 8 pi over 4, I get a total of 15 pi over 4. Right? So that's a coterminal angle. It differs by 360 degrees, or in radians case, it differs by 2 pi, because 360 and 2 pi are the same thing. So I'm adding different chunks of 2 pi. And the way I tell how much to add is I look at what the original denominator is, and I put double that amount on top over the same denominator. That's how we make our 2 pi here. All right, now with our radians comes our reference angles. And so on each of these slides, I'm just going to show real quick, and we can talk about this and build this up a little bit more in class. But each of our angle measures has a reference angle, and each of our reference angles has both degrees and radian measures. Now, the ones that we know so far are really important ones are 90, 45, 30s, and 60s. Well, the 30s and 60s and 45s and 90s, they kind of give us a bunch of different angle measures. In radians, though, there's kind of a nice set of patterns that occur. For all of our 90-degree reference angles, so in this case, that's 0, 90, 180, 270, 360 degree angles, all of them are going to be either whole chunks of pi or some value of pi over 2. So 90-degree reference angles, all these quadrantal ones, are either whole chunks of pi or some number of pi over 2. So you can check it out here. We have 0 pi, pi over 2, 1 pi, 3 pi over 2, 2 pi, and it would just keep going. When it comes to the whole chunks of pi, all of our even whole chunks of pi are on this side, and all of our odd chunks of pi are on this side. So if for some reason you had 7 pi would be on this side because 7 is an odd number. 12 pi would be on this side because it's an even number. If we wanted to figure out whether we're in one of these, you can always just add or subtract to find your coterminal angles. So you're always just going to add and subtract different chunks of 4 pi over 2. If you add and subtract different chunks of 4 pi over 2, it'll get you back to one of these angles that you can evaluate. Keeping going, our 30-degree reference angles are all going to be some value of pi over 6. Now, the way I like to think about it is in quadrant 1, I have 1/6. Half a circle would be 6/6. So right before that is 5/6 pi. And right after that is 7/6 pi, or 7 pi over 6. So that's how I always kind of remember what these are. Half a circle would have been 6/6, but a little bit less than that is 5/6, a little bit more than that is 7/6. Now these are all 30-degree reference angles. So we should know our 30-degree reference angles, like this is 30, this is 150, this is 210. These are all degrees, by the way. And then the last one is 330, but this is just the radians way of mentioning them. Okay, so pi over 6 is the same as a 30-degree reference angle. If you see some pi over 6, it means it's a 30-degree reference angle. Now, if you're trying to get back to one of these four, so that way you can evaluate something and you know exactly what quadrant you're in, what you're going to do is you're going to add and subtract chunks of 12 pi over 6, right? So if I have something like negative 15 pi over 6, I know it's a 30-degree reference angle. I might not know where it's at, but what I'm going to do is I'm going to add 12 pi over 6 and add another 12 pi over 6, and that'll get me back to my 0 to 2 pi range. That way I can evaluate it. All right, going. Our pi over 3, all of our pi over 3 is going to be a 60-degree reference angle. So all of these are 60 degrees. So this is 60 degrees, this is 120 degrees, this is 240 degrees, this is 300 degrees. It's just a different way of listing it. If I want to find the coterminal angles for any of my pi over 3 or 60-degree reference angles, I'm going to add and subtract chunks of 6 pi over 3. So if I add 6 pi over 3, that's like adding 360. If I subtract 6 pi over 3, it's like subtracting 360. I can just keep adding and subtracting 6 pi's over 3 until I get back to one of these four angles, so that way I could evaluate. All right, and our last one is any 45-degree reference angle is going to be pi over 4. Okay, so any 45-degree reference angle is a pi over 4. So pi over 4 is 45 degrees. 3 pi over 4 is 135 degrees. 5 pi over 4 is 225 degrees. And 7 pi over 4 is 315 degrees. Just like I was saying before, the way I always try and remember it is my first pi over 4 is pi over 4. My next one is 1 less than 4/4, and then 1 more than 4/4, and then 1 less than 8/4. That's kind of my nice way I like to memorize these, and I'll practice that with you guys a little bit more in class. If I want to find coterminal, just like before, I double the denominator, so it's plus or minus 8 pi over 4. If I want to try and get back to one of these four, so that way I know where I'm at and I can evaluate. All right, last but not least, let's go ahead and let's try a practice problem or two. I'll go ahead and do maybe 2 of them. I have one already written right here. So the first thing I'm going to do is sketch a picture. All right, so I have 3 pi's over 4. So I draw a little quadrant. All right, 3 pi's over 4. So over 4, I know that's a 45-degree reference angle, right? Over 3 was 60. over 6 was 30, over 4 is 45, and 3/4 is a little less than 4/4. So 4/4 would have been half a circle, so 3/4 is the quadrant before half of a circle. All right, so I know this is a 45-degree reference angle here. So I know my opposite side is 1 because it's going up. My adjacent side is -1 because it's going to the left. My hypotenuse is √2. If I take the tangent of this, the tangent is the opposite over adjacent, which is 1 over -1, which is -1. So there we go. The tangent of 3 pi over 4 radians is -1. Let's go ahead and try a different one. Let's make one up real quick. So another one, let's go ahead and let's do the sine of, let's say 11 pi over 3. All right, so this one's a little tricky. We need to do a little bit of math here to find a coterminal angle that works. So what I'm going to do is I'm going to subtract, and I can do this math kind of off in the margin. I have 11 pi over 3. I'm going to subtract 6 pi's over 3, which is 2 pi or a whole circle, and I get 5 pi's over 3. So that's my coterminal angle, so I can use that instead. So sine of 11 pi over 3 is the same as sine of 5 pi over 3. These are the same angle. They're in the same location, so I know where 5 pi over 3 is a little bit better than 11 pi over 3. I'll draw that angle. 5 pi over 3 is a little bit less than 6 pi over 3, which would be a full circle. So I know I'm somewhere over here in quadrant 4. Let me change my color back to purple. Somewhere over here in quadrant 4 is my triangle. Since my reference angle, since my denominator is 3, I know my reference angle is 60. You gotta be careful up there. Denominator of 3 is reference angle 60, which means my opposite side is -√3 because I'm going down. My adjacent side is +1 because it's going to the right. My hypotenuse is 2. If I take the sine of this, that's opposite over hypotenuse. So this is -√3 over 2 for my answer. All right. With that, you should have enough information to be able to get started and attempt the homework. I'd be glad to help you guys out if you have any questions. We're going to go over this a lot more and practice this a lot more in class. Once again, please reach out if you need anything. Otherwise, I'll see you in our next live session. And until then, I hope you have a great day.